In this lecture, we are going to talk about arrays and pointers in the assembly, even though you usually see these kind of concepts in the higher level programming languages, but in here I just want to show you how they get implemented in the assembly. Or we just create some kind of mapping. So in here, first we create a file. Let's name it just arrays.nazm, and we create our start label, section.text, section.data, and in here just the start entry point. Now in the data section, I want to say create a label called, let me name it my array, define some bytes, 0x1, the character D, 0x just 22, 54 in the decimal, and 0x 12 in here. Now if you notice, we have created it, this line is exactly what it does is that it exactly creates an array. The my array label is a pointer pointing to the first element of this array, and using the my array, which is just, as I said, the address of the first element, we could access all the elements in here, which is actually the definition and the concept of arrays or list. And later you would see in the other programming languages that when we create an array like this, for example in C, the name itself would actually be the same thing, a pointer to the first element of the array. Now in here we want to see how we could access any one of these elements or the address of any one of these elements in this array. So in here, first I want to say move R9 and then my array. This would cause the address of this array or the address of the first element, which would be the same thing, or the name of the array, to the R9 register. And after that I want to move the my array address +1 to the R10 register, which would give us the address of the second element of this array in the R10 register. After that I want to use the first 8 registers of the RX register, which we could have access to using the AL, and then I want to just move the D character inside it by saying my array +1 inside the brackets. This would cause the contents of this address, which is correctly D character, inside the AL register, and because both of them are 1 byte, so we wouldn't have any problem. And then I want to say move RAX and then the same thing, my array +1, to see what would happen. What would happen if you use only 8 bits of the RX register or all of the RX register. And after that, well, I think that's it. I want to now check it using the GDB. So I press Ctrl O, hit enter, Ctrl X, assemble and link it. Now if we execute it, before I execute, I think now you would know that the result would be some kind of segmentation fault. So if I say arrays, as you see we have segmentation fault. The reason that I explained a lot of times in the previous lecture is that because we haven't exited from the program, therefore after this the RIP would be filled with the address next to this instruction, which would be something that we don't want or we haven't predicted. Therefore the instruction might be an invalid instruction, or it would cause it would ask to access some memory addresses which we don't have access to, we aren't permitted, therefore we get a segmentation fault. So I press Ctrl Shift and T in here, enter the GDB, hit enter, create a breakpoint at the start, and then run it. I also press Ctrl Shift and T and use the obj dump in here to see all the instructions in the text section. And now we say info registers RIP. So right now RIP is 4000B0, which is actually pointing to this address this instruction in here. The my array has been translated to its address. That's why in the output, because we are using the executable in here, so we see the addresses of the label. We have 0x6000D4, which would be the address of my array in here. You want to move it inside the R9 register, so I just say step I, and we would have a look at the R9 register. As you see, we have 0x6000 and D4. After that, we want to move the next address inside R10 register. So right now R10 is 0, so I say step I, and then have a look at R10 register. We have 0x6000 D5 inside the R10 register. Now these are the important parts. If you look, first we want the contents of the myArray plus 1, which would be the content inside the 0x6000 D5. So first I want to use the X command to see the byte at 0x6000 D5. If I hit enter, as you see, we have the value of 0x64 in the hexadecimal representation, which is actually the value for the D character. If I press Ctrl Shift and T and use the man ASCII, the 64 in the hexadecimal in here would be actually for the D character. The D character in here has been moved inside the it's at this memory address, and using the step I, we are going to move it inside the AL register. So right now the AL register, if we look, it's equal to 0, but when we say step I and have a look at AL register, we have the 0x64, which has been moved from has been copied from this memory address inside the AL register. But the last address is what would happen if we move the same thing inside the RX register. Well, the thing is that right now RX register is 64 bits or 8 bytes. Now when we say I want to move the contents at this address, it would get 8 bytes or 64 bits, because the destination operand is 64 bits, and move all of the values inside the ArrayX. Let us prove that. If I say info registers and ArrayX, well, the only thing that we have is 0x64, which means that only the first 8 bits of the ArrayX, which is the AL register, has been filled. The rest is just equal to 0. Now I say step I and then have a look at the ArrayX register. If you look, now we have this value, even though the AL is still 64, but the ArrayX register has been moved with the 12, 36, 22 and 64, which are all this value. You just read it in the reverse order. Well, we have 64, which is for the D, the first element. We have 22, it would be this. Then we have 36, which is actually the hexadecimal equivalent of the 54 in the decimal. And at last we have the 12, which, if you look, this is the 12. But now you might ask, well, these are just 4 bytes. How is it that we only moved 4 bytes even though the operand is 64 bits or 8 bytes? Well, the reason is that actually we have copied all the bytes, but the rest are 0. Now, how we could prove that? If you look, the address of the D character was this one. Actually, let me just use the up arrow in here. If you look at 0x6000 D5, we had 0x64, right? What about D6? Well, it was the number 22, which is the address of this element. This is the second byte. The third byte would be 36, which we said is the hexadecimal of 54. D8 would be 12, which is the last element and fourth byte in here. The rest of the byte, we want to check them as well. D9, as you see, is just 00. We have 3 more bytes. DA is again 00. DB is 00, and DC, which is 00. So we have moved 8 bytes in the RX register, and we could just see it in this way. So if you, depending on how many bytes you want to move from the memory or from your array to different registers, you should use different portions of the registers, I guess.